Hello. This is Mr. Wong. Other than teaching physics, I also teach STEM. So today I would like to show you how you can create a game called PaperScissorsRock. I think everyone knows that, but using the micro:bit. As you know, because of the COVID-19, we can't really have the actual lesson in school, and so it's always a problem for us that to deliver the STEM lesson because we don't have the hardware simply. However, I find on MicroBit's website MicroBit, there's actually something called the multi-editor, which allows us to use the radial function of MicroBit properly. And today I'm going to show you how you can build the game through the radial on PaperScissorsRock. First of all, I would like to show you how the basic radial function will work in this multi-editor. So first of all, let's just start to create our project as PaperScissorsRock. I'll call it PaperScissorsRock 1 on the left and the same as 2 on the right. I think I will avoid using the same name in case the system will clash. I think that's something you will want to do as well. And first of all, you can see again the environment is exactly the same as how you do with the usual block coding in MicroBit. And so the only thing is different will be the simulator now is on the bottom right in order to save the space, I suppose. And so let's try to do it. So if I want to send radial, I will definitely need to set the two micro:bit in the same radial frequency, or they call it group in micro:bit. So say I would like to use number 1, 2, 3, for example, or actually you can keep it as 1 if you like to. And then let's say I want to send a string. All right, when I press button A, then I press it. I'll send out a string called A, and then when I press B, will then be B, and maybe when I press A plus B, then it will be AB. Okay, and so if you do it this way, then you'll find out if you try the simulator, it will pop up. There's like a pulse, right, which show the idea of radial with different strength of radial signal, I suppose, with the number you can see here. But then the thing is, nothing will happen other than this because I didn't ask the micro:bit to do anything else. So the next thing that you like to do to test the basic function of radial wave is you can set on the right hand side when these receive a string, which could be A, could be B, could be A and B, then maybe it's the best here. All right, be careful. You can't actually drag this and expect this can be dragged on the other side. So you really have to pull out from the correct side. So here you want to show not 0 but the string is that. So I can pull like this actually. Oh, actually it's not number. Okay, I make a stupid mistake here. String. So that's why I can't plug in. Okay, so if that's the case, let's try it out. Okay, if I press button A here, you can see on the right, through the radial, of course, in reality, then the display will be shown. So A, B, or A plus B will be shown as AB. Okay, and this is what happened when you receive a string. You can also see that it is not forever. So like, for example, for A plus B, I think it only shows once, yeah, and then it is gone. So this is the basic idea of radial function. The most important thing about the multi-editor is it is two-way. If you do it in a traditional setting, you can still try the radial signal, but then it is a one-way radial. So if you try to do the editor simulation right now, you'll find out if I press the right-hand side that micro:bit, it doesn't do anything at all, right? Because in this case, if I want something to happen, I really have to get the similar codes on the right as well, which could be sending out a radial number this time. Let's try out number. So let's say 1, and maybe button B for 2, and then maybe A plus B as 3. Alright, and then on the left hand side also you have to receive the signal, alright, in order to know, I mean for you when you test it, so then you know. This time I should not be using receive string because obviously I would anticipate receiving a number. So I can use receive number And then of course you can do other things that you like, or maybe if you are sending a temperature or light intensity, you can do something else, like plotting a graph, etc. So here I could simply show the number, which is the number that I receive. Okay, and let's try it out. So like the previous, when I press A and B on the left, yes, it shows A, B, or AB. At the same time, I press this button. Similarly, if I press A here, you can see 1 here. When I press B, it is 2. A plus B becomes 3. So this is a basic idea of how you can communicate the 2 microbits in the simulator with two-way direction. Okay, so for now, what I want to do is I would really start to do the PaperScissorsRock thing. And so I would actually need to work on one side only, because the other side probably just to duplicate once. So I just have to focus on one, otherwise I will take the same amount of time to just pull out the block, which is a waste of time. So here, I think I will clear this out. And yeah, I think I'll just do it like this. And so the first thing that you may want to do is that, because when in my imagination, when I play the game, what I do is I would have the microbit. Sorry, I don't have microbit right now, but imagine this is a 1. Then I will expect when I play with someone else, I would shake the microbit, because normally when you play it, you do like this, right? And then you do whatever choice you make. So when I shake the microbit, then that would change the temporary choice of yours. So it rotates from paper, scissors, and rock until you click the confirm button. Okay, and after you click the confirm button, and also upon receiving the signal from another microbit, then the match will be automatically generated, and the result will be shown on the microbit that LED, and after a while the game will be restarted. So this is what I want to do to show you as an example today using the radial function. So first of all, I would like to set up a variable called pick, and that will represent the choice that you make, and I hope that would be changed when I shake it. So like I said, your choice will be changed, and in this case then I will change the number by 1. But then if you think about it, then you can foresee it will keep going and going and going until it is 4 or 5 or 6, which you don't want that, right? There are only 3 options in PaperScissorsRock. So here I would think of using a way to just keeping the number in the loop when pick is exceeding 3, when it's equal to 4. Then I will change its number back to 1 then. So through this, I guess what happened to pick will simply be looping from 1 to 3 and then back to 1 again. Of course, there are other ways of doing it. Some of you may be think of using the while loop right here, or you can use some sort of mathematical way of calculating the remainder of the number. So there are different ways of doing it. Or if you like to start with 0, that's fine too, 0, 1, or 2. So you can have different approach when we do programming. Alright, so the next thing that we would like to do is to show on your screen, so then the person who play the game get to know that the current choice that you are now making before confirming. So I would say using a for loop, again, there are different ways of doing it, but then I would do this way. So what I'll do is in the forever loop, I will choose for the pick when it's equals to 1. Then let's just start with paper, and for the symbol you can choose it yourself, but then I would go with this symbol which looks like a square. And then what you can do is you can do the next part, which is when this is equal to 2, then paper scissors. So let's just do scissors, and I would like to do like this. Alright, hopefully you can understand this is a scissors. And if not, then the only choice, you don't have to say equal to 3, because there's only 3 possibilities. So if not 1, if not 2, then it must be 3. And that will be rock. So for the symbol, you can choose wherever you like, but for me, I will do it this way. Alright, so in this case, we should get the display ready before it got sent out to the other microbit through radial. So let's just try it out. So in this case, when I shake it, it become, I think this is paper, scissors, and rock. Yeah, and you can see it keep looping forever. Okay, to make it more dynamic, you know, more like really like a game that is a bit more attractive, I actually try to put it to be blinking, so I can put a all black LED here, so all off. So in this case, what you'll see instead is more like those arcade game where it starts to blink to remind you that this is the choice that you are now making. Alright, so then it will, yeah, I feel this is more like vivid and dynamic. Okay, so this is the display of changing your choice, and the next step we'll try to do is how to send through this in the radial. Alright, so the next thing that I'd like to do is to send out the radial signal which contain the choice. So here I would like to send out the number simply, because I think if you send out the word paper, scissors, and rock, it just takes so complicated. So I'd rather use a number, and when I try to send out this number, you can see this is gray in color, so there must be some sort of action to be done first. I don't want to put it in the forever loop, because in that case that means you keep sending it out every second. Then I don't think you want to do it like this, because you want to confirm. So another action other than shake before you confirm that's your choice. So here I will choose button A. Of course you can choose other things like B or A plus B, or if you like to plug in some other things like an external button module, that's fine as well. There are other choices like acceleration or like tilting, or if you like to use something like those, should be fine as well. But then I think using button A is just more handy and reasonable. So what I would like to send out should be the variable peak. Alright, so then the other microbits will be able to receive it. At the same time, so imagine these will get to repeat the same kind of blocks and cooks on the other microbits, then that means you should also receive a number as well, alright, which is the other person's pick. And here we have to do a bit of thinking before we move on. So we have assigned the number 1 to paper, 2 to scissors, and 3 to rock. And according to what you learned in your childhood, then you should know that paper would win rock. So that means 1 would win 3. And rock would win scissor. So that means 3 would win 2. And 2 will win 1, because scissors can cut the paper, so 2 will win 1. So this is the win situation. Same for the lose, will be the other way around. There's also a time where you draw the game, which means when both numbers are the same. So once again, there are different ways of doing this algorithm, but the way that I do probably is I will do the minus. So if you think about that, whenever the two numbers, again representing the choice between two microbits, if the equation is, say, yourself, the number of yourself minus the opponent, then if that's the number that you're obtaining, and if that's equals to 0, then that must be a draw between your game, right? It will be a tie of your game. When you try to do this, then if you are in this win situation, you can see that this would equal to -2, this should equal to 1 positive, this would equal to 1 positive. So I think my plan is I would like to check whether it's equal to 0 first, and then to check whether it's equal to 1, and then check, if not, then check if it's either to -2. Then if it fall into these cases, then it will be either draw for this case and win for this case. Similarly, for losing, then it will be the other way around. So for losing, it will simply be 3 to 1, which is the opposite of this number. So let me just copy it. And so that means the answer would then be 2, -1, and -1. So I think I can use the index, the blue numbers here, to help us to do the codings later on. Back to the program. The next thing that I would like to do is to set up a new variable to store the number, because you probably would need to refer to it quite often. So for calculating the number, like I said, there's a very simple equation called the number of yourself minus the opponent one. So that would be from maths. doing the minus. Okay, and I would use yourself, that means the number called pick and the number upon receiving. So I have to put it inside this so that I can plug this in, because this number only work within here. And so that should be the number that you have. And the next step is to think about how to decide you are winning or you're losing or it is a draw. So refer back to our planning here, then let's do the draw first. So I think that's easy. So if the number which is match equal to 0, then obviously it's a draw. So what you want to do is you want to show an LE, well, you can display the letters of draw type, but then I guess I'll just prefer a emoji maybe. So maybe like this face, I don't know how you call it, poker face. And then if you are winning, then it's going to be -2 or +1. So that is to say you want to add one more condition. That is there are two, right? Because it's either -2 or 1, so I will want to change it to or and plug in here. So it is either, actually I can steal this one and duplicate, it's faster. Okay, and if it's equal to what again, -2 or equals to, okay, this taking up so much space. But if it is -2 or +1, then it is winning, right? So let's just show a happy face. Is it good? I think this is this. I think this. Okay, how about this one? Alright, just now that one is a bit creepy. Okay, so if these are not the case, actually, I actually don't have to put down anything because these should be all the case. So that means if it is not 0, not -2, not 1, then it must be 2 or -1. So you don't actually have to force another statement here. So I guess I will just leave these as lost. So that should be a sad face like this or this. Okay, this is a bit strange. I think I'll just do this. Okay, so okay, I think I'll do this. This is draw, this is win, and this is lost. So oops, I think I'll just do this. Yeah. Okay, so I want to hold this for a while because otherwise it will just show in like a very brief second and then it will just be gone. So I want to hold for say 2 seconds maybe, then you can see the result. And then what I would want to do is probably try to do a test first. So like I said, you don't want to do the whole thing again on the right hand side because it's kind of waste of time. So what you can do is you can download the file and put it maybe right here, and I'll name it as 2 actually, and then I would pull this back again. Okay, and I can pull this here. So in that case, you can now see they are exactly identical. So what I can do is, I don't know why the simulator is gone, but maybe I can record here. Okay, and here. So you can see that these are the choice that we're trying to make. And so let's just try to do a game that is draw first, shall we? So when I press A here, you can see just now on the right hand side, right, become a smiley face. Okay, but then I think it's a bit strange here. Now cause the choice somehow after 2 seconds go back to scissor. And then okay, let's just try again. Paper and rock. So sad face. Alright, so it's interesting that for some reason when you press A, it's only the opponent showing the result but not you. Okay, and also the other thing that I mentioned before, as in the button A is for confirming, right? So I should somehow set the code so that both of the microbits would confirm before I try to make the comparison. Otherwise, it doesn't make sense. Maybe like the one on the right is still making a choice, and then suddenly the left hand side, that one, press A, and then you somehow stop the game from going onwards. So that is not something we want. Okay, but then at least I think for comparison, it's working quite well. Okay, paper, rock, so then these, yes, the right hand side should lose. And if it's both papers, then it's a poker face, and this means draw. If it is the yellow one will win, then yes, alright. So the match judgment is correct. It's more about confirming right now. Okay, so what I would do is I would make another variable that is called confirm, and for confirm key it should be 0, I suppose, alright, at the beginning, and only when you press button A it will become 1. Okay, that means you have confirmed that you will do it. So when you receive a signal, that means the other person, the other microbit has already pressed the button A. That means it must be confirmed. So that means when you make the match, you only do it when you are confirmed and also you have received the number from the other person. So I guess right now what we need to do is to pull this out. Actually, I can't keep this inside because there might be a scenario where the other person would have confirmed long ago before you. So you shouldn't be showing any numbers before you confirm, right? So I will keep this in the forever loop instead. So if you have received a number from the radial, then you will get to know the number as match. So I would need to Alright, so it actually took me some time, more than I expected, to work out the solution. And let me show you my result first. So say here, let me restart the program just in case. So you can see this is showing rock on both sides, and then when I shake it, it becomes like how just now it happened between the three choices. So let's say it is, let's do a draw game first. Let's do scissors versus scissors. And so what happened now is, after I change the codes, when you press button A, you send out a signal, and you see just now on the left hand side there's a tick. Alright, that means that you have confirmed the choice. And right now, if the one on the left keeps shaking, you can see right now I'm clicking the shake button. It doesn't change the choice anymore, so it kind of locked down your option, your choice already, and you can't change it anymore. And for B, I mean, of course, it's still free to choose, but then once B press button A as well, then the match will start. Okay, so you can see both of them now show a sad face, not sad face, poker face. That means this is a draw. Okay, so let me try to do another scenario. So say, let's do paper and scissors, right? So left should be lose and the right hand side should be a win. Okay, so this time let me just confirm this one side first. Okay, so you can see a ticket again, and it's not done yet. But then here I would press button A. Alright, and yes, right hand side is win, left hand side is lose. Okay, and let me also do other scenario so that this time the left hand side will win. So let's say rock and scissors then. Okay, confirm and confirm. Yeah, so win and then lose right there. Okay, so this is basically what I want. Alright, that's all I want when I plan to do this game. And imagine if you have two microbits, you can use radial to communicate and play this game with a certain distance. So as I read from the official website of microbit, it can go up to about 50 meters. Alright, so imagine you're in one classroom and your classmate is in another classroom, you can somehow secretly play this game. NANI? Of course, I'm not encouraging you to do that during the other lessons. Alright, so let me explain my codes. And it may look a bit lengthy, and I guess this is again the most intuitive way that I could think of. If you can somehow shrink down the length of the codes, please leave a comment below and let me know how you can make it better. So I actually have made 4 variables, which again I do think may not be necessary. So again, we have variable pick, which indicates your choice, Now I've made opponent as well. So opponent will be the number that store the radial number that you receive directly. So that means your opponent's choice. So it should be also between 1, 2, or 3. The reason why I will store it in another variable is because for the received number, you cannot store it outside. Like you cannot work. I mean, you can put it out, but then you can never plug it in because this is something to do with the programming design itself. The number that you receive from the radial can only work within the block here. Okay, so it's more like we call it local variable instead of a global variable. So the one that you set these for are global variable. You can use it anywhere inside this function or anywhere. But for the received number, it can only work under this radial block only. So that's why I would like to copy it out so then you can process it outside. The other variable that I made other than match, of course, match is like what I showed you in the previous part of the video, which should determine whether you win, lose, or draw. I also make a new variable called confirm because this is something tricky that took me quite a long time to realize and work out smoothly. Is whenever you make a match, right? There are two things you need to do. One is to make sure you have pressed the button A in my design. At the same time, the opponent, the other microbit, also pressed button A. So these two will need to be confirmed before you make the judgment. Okay, and so that's why other than opponent, because whenever you have the opponent number, that means you have already received the signal. You also need a button for yourself and a variable for yourself to make sure that you are ready to make the match. And I also want to keep a way to lock the option as well, so you can't be changing at the last minute. When you press confirm, it's really confirmed. You can't change your choice anymore. So that's why I would need a new variable called confirm, or you can name it other way. And to give the user a better understanding, I use a tick to show whenever you press the button A. And so that's why here you can see I also change the shake function here with a if loop. So that means if confirm is 0, you can continue to change. You are free to change. However, whenever you press the button A, maybe I can put it here. Whenever you press the button A, then the confirm variable has changed to 1, and you can no longer enter this loop. You can't go inside. So that means you cannot change. Even if you shake it, it's useless, right? So that's why once I confirmed just now in the simulation, you cannot change the display anymore in this case. Alright, and for initialization, I would set pick as 0, confirm as 0, opponent as 0, so that you can, at the beginning of your program, you can enter this loop directly and you can change it before you press button A. And so down here, if you have already received the radial answer, like the number from your opponent, and also you have pressed a confirm button, then that means you have fulfilled the one here. You have fulfilled this criteria, which is opponent and confirm equal to 1 and opponent greater than 0. The reason why I say it as greater than 0 means that because, as we know, opponent can only be either 1, 2, or 3, right? Again, representing paper, scissors, or rock. Then that means they have made a choice. So if they have made a choice and we also confirm, then we will finally do the matching. So the matching, this part will be exactly the same as what I showed earlier, and this will be a loop that actually I don't have to use while loop. I can actually use a if, right, to cover this up, because this will only run one time only. Yeah, I think I better change it actually, but never mind, it works, so I don't care now. At the end, after I show the result with the LED, I will now hold it for 5 seconds. I think 2 seconds was a bit too short just now, so maybe 5 seconds is a bit better. And I will also reset the opponent choice as 0. The reason is that, of course, there's no such a choice called 0, but you can imagine 0 is like empty, right? You can initialize it to be empty, so that when you are 0, I mean opponent is 0, then you would not be entering the judgment loop again, because here the condition is opponent greater than 0. So that means if opponent equal to 0, you would not do the following. That means you won't judge anymore until you have received a number from your opponent. Okay, so making these resets is very important so that the game can be replayed over again. Same as yourself as well. The confirm button will be reset to 0. So only when you press the button A again, where is it? Oh, here. Button A again, then you get to do the match again. So this is the code that you need to make the simulation that I showed you just now. And for the other microbit on the right hand side is exactly the same. Lastly, as a bonus to add more excitement to your game, you can actually consider adding the music. So here I can find the block called Start Melody, and I would put it after showing the result of your match. And so this is draw, so maybe I have no idea what to do, so maybe I can show a ding sound. I don't know whether that's the case. And for smiling, that means winning, let's do power up, and losing, let's do power down. Okay, and I will have to do the same on the right hand side, so let's just download it, alright, to save some time, and then we'll try to run it on the 2 simulator. Okay, here we go, and I think here it is. Okay, so you can see the simulator got changed a bit because supposedly you have to connect a buzzer to it, but then the simulator will also provide you the music as if you have connected to the buzzer. Alright, so let's try. Let's do paper and paper. So let's see how it goes when it is a draw first. Confirm, confirm. Okay, sounds like those like coin of the Mario game. I guess it's okay. I guess doesn't sound quite right, but then I'm okay with that. Let's try win and lose. So unfortunately, it is on the simulator, and for the music, it will just play at the same time. So it might be a bit confusing, but let's try. Confirm, confirm. Yeah, I think it's alright. I mean, the winning one sounds quite joyful, and while the losing one sounds like a frustration somehow. Okay, so I'm quite happy with my music choice here. That's all for making the game today. I hope you enjoy learning with me. If you do so, please hit the like button and subscribe to my channel. Next time I will show you how the program look like on the real microbit. Thanks for watching. Peace.